Hello guys, welcome to this science paper 1 presentation. So if you're new to this channel, subscribe for more videos like this. So the first question is saying a wooden block is pulled along a bench. So we have two forces acting on the opposite to each other. So we have the first one which is 1.8 newtons, then the other one which is 1.2 newtons. The question continues. The block moves toward the light. So the block moves on this side here. So the sizes and the directions of the horizontal forces acting on the block when it is in motion are shown in figure 4.1. Question A. The horizontal force of 1.2 newtons acts in the opposite direction to the direction of motion. So when it comes to the forces, the force which opposes the motion is called the friction force, meaning 1.2 newtons is called the friction force. Now, Roman numeral 1 is saying, state the name of this force. So we are just going to say, this one is going to be the friction force. That's the answer. Then as for Roman numeral number 2, it is saying, calculate the resultant force acting on the block. So we need to calculate the resultant force here. So to calculate the resultant force, we are going to say the resultant force is going to be equal to the driving force. In this case here, the driving force is going to be 1.8 newtons. Then minus the friction force, which is going to be 1.2 newtons. Then our final answer is going to be 0.6 newtons. Meaning our resultant force here, it is 0.6 newtons. So 0.6 newtons is our answer. Let's see the next question. Question B reads, the wooden block has a mass of 2.0 kgs. Then as for Roman numeral number 1, it is saying, state the equation linking mass, force and acceleration. Here they are talking about Newton's second law of motion. As you can see from this diagram here, we have two forces which are unbalanced. They are not balanced, but they are unbalanced. So when you talk of Newton's second law of motion, it said that unbalanced forces acting on an object produces an acceleration in the direction of the force. Meaning, once you compute the resultant force here, you're going to find that on this part of the friction force, you're going to have 0 newtons. Then on this part of the driving force, you're going to have 0.6 newtons. Meaning, this wooden block is going to move on the right hand side. Now, here we can say the equation which links mass, force and acceleration under Newton's second law of motion is going to be force being equal to mass multiplied by acceleration. Then as for Roman numeral number 2, it is saying, using your answer in Roman numeral number 2, which is for A, calculate the acceleration of the block. So we are going to say the resultant force now in A, Roman numeral number 2, it is 0.6 newtons. Then as for the mass of the wooden block here, it is 2. The resultant force, it is just 0.6 newtons. Then the mass of this wooden block, it is 2.0 kgs multiplied by the acceleration. So once I divide by 2.0 kgs, even here by 2.0 kgs, these two, they are going to cancel each other. Therefore, I'm going to remain with A, which is the acceleration. So when I divide here, I'm going to get 0.3 meters per second squared. So usually acceleration is measured in meters per second squared. So we are just going to say 0.3 meters per second squared. As for meters per second squared, they have included for us. Let's see the next question. So the next question is coming from waves, and it is saying, figure 6.1 shows how the displacement of a transverse wave varies with time. So we have the displacement of the wave in centimeters, and also the time taken for these waves to be produced, and it is in seconds. Now, as for the first question, which is question A, Roman numeral 1, it is saying, determine the amplitude of the wave in figure 6.1. So the first thing here, you need to know the definition of the amplitude. So the amplitude is defined as the maximum displacement of the wave. So the wave is coming from the initial position here, or initial point, up to this point here, which we are going to say this one is going to be the maximum displacement. Now usually, as for the amplitude, we can say it is from this point here up to this. That's the amplitude that we have. Now, according to the displacement that we have here, since I'm saying as for the amplitude is just the maximum displacement of the wave. So in this case here, the amplitude is just going to be 2.0. When it comes to this part here, where you come from this one up to this point here, this one is called the minimum displacement of the wave. Then as for Roman number 2, it is saying, determine the frequency of the wave in figure 6.1. So the first thing here, we need to know the formula for calculating the frequency. So frequency is equal to the number of successive waves divided by the time taken for successive waves to be produced. Now, by definition, we can say frequency is the number of waves or successive waves produced in 1 second. Now, how are we going to determine the successive waves here? So one thing that you need to understand here is that the maximum displacement of the wave, which is the amplitude in this case here, and also the minimum displacement of the wave makes one successive wave. Meaning from this point here up to this point here, we are going to have one successive wave. Then from the same point up to this point here, we are going to have another successive wave. So from this graph here, we have two successive waves that we have. So we can say the number of successive waves that we have here are just going to be what? 2. Divided by the time taken for these successive waves to be produced. So the time that we have here, it is just 0.4. So we can say 0.4 seconds. Then when I divide, I'm going to get the answer, which is 5 Hz. Usually, the frequency is measured in Hz. So we are going to say 5 Hz. So as for the Hz, they have included for us here. The next question. The next question, which is B, is saying, describe the motion of particles in a transverse water wave. So now, according to this graph that you can see here, when the wave moves from this initial point up to the amplitude, up to the maximum, up to this maximum here, which we are going to say the maximum amplitude. If we consider the amplitude from this point up to this one here, the particles are going to move upward. Then when it comes to this point here, when the particles move from this one up to this point here, they are going to move downward. So we can say the first one is going to be the particles move up and down. So particles move up and down. Then as for the next one, we are going to say the particles move perpendicular to the direction of the wave. So we can say particles move perpendicular to the direction of the wave. Then the last one we are going to say, since here they are talking about water wave or water waves. So when waves are produced on water, you are going to find that limpos and ponds are going to be formed. So we are going to say limpos and ponds are going to be formed. So those are the answers. As for C, it is saying a wave has a frequency of 400 Hz and a wavelength of 0.90 meters. Then the question is saying, calculate the velocity of the wave. So using this formula here, where we are going to say velocity is equal to the frequency multiplied by the wavelength, which is going to be in form of the lambda. We can say the frequency that we have here, it is 400 Hz. Then when it comes to the wavelength that we have here, it is 0.90 meters. Then when I multiply here, the answer is going to be 360 meters per second. So here the velocity is measured in meters per second. So we have meters per second here. The next question. So the next question is coming from electricity, specifically static electricity. So it is saying, a student uses a dry cloth to rub a plastic rod. State how the plastic rod gains a positive charge from friction between the cloth and the rod. In this case here, they are just asking us how the electrons are going to move. So the first thing here, you're going to find that electrons are going to move from the plastic rod going to the cloth or the dry cloth. So we can say electrons or negative charges move from the plastic rod to the dry cloth. Then apart from that one, you can also say the positive charges move from the cloth or the dry cloth to the plastic rod. So these are the answers for question A. Then as for B, it is saying 3 balls P, Q and R are electrically charged. The balls are suspended by threads of insulating material. Figure 8.1 shows the arrangement. So we have the insulated thread here, and P having a positive charge. So now as you can see here, we have a space here. For us to have a space here, meaning there is repulsion. Now if there is repulsion, meaning Q is going to have also a positive charge, because likely poles they repel, or likely terminals they repel. Then unlikely terminals they attract, meaning R is going to be a negative charge because here there is attraction. So let's see the question. So it is saying the charge on P is positive. State the charge on Q and the charge on R. So as for Q, as you can see here, there is a space here, meaning this one is going to be a positive charge, because as for likely terminals, so if you have positive, positive, there will be repulsion. Negative, negative, there will be repulsion. Now as for the positive and negative, you are going to have attraction here. So this one, repulsion. This one, repulsion. So you can say as for Q, it is going to be a positive charge. Then as for R, it is going to be a negative charge. Then as for C, it is saying the student connects bulb P, which is having a positive charge, to earth with a copper wire. The charges from the earth flow in the copper wire to bulb P. State the name of the electrically charged particles moving in the copper wire. So in this case here we have P, which is having a positive charge. Now I'm from saying that positive, positive, they repel. So we have P having a positive charge. Then the particles are flowing from the earthworm going to P, meaning those particles are going to be electrons or negative charges. So you can say electrons or negative particles. Then as for the next question, which is coming from light or electronic propagation, it is saying the angle of incidence is 22 degrees and the angle of refraction is 15 degrees. So we also have angle A here. Now one thing that you need to understand here is that when the ray is coming from lower dense medium, which is the air, going to the high dense medium, after passing through the normal, so this one is the normal ray, after passing through the normal, it is going to bend toward the normal. So as you can see here, this ray is bending toward the normal. Now when the ray is coming from high dense medium, which is the glass block here, going to the less dense medium, which is the air, it is going to bend away from the normal. So here it is bending away from the normal. So now, one thing that you need to understand here is that the angle when the ray is entering, which is going to be formed between the incident ray, this one is the incident ray, and the normal ray, it is going to be the angle of incident. Now that angle is going to be equal to the angle when the ray is leaving the glass block, meaning the angle here, on this part here, it is going to be 22 degrees or so. Now the question continues. Now the question continues here. It is saying the ray passes through the glass and emerges into air. Calculate the refractive index of the glass. So refractive index represented by small letter n is equal to the angle of the sine angle of incidence divided by the sine angle of reflection. So you can say the sine angle of incident here, it is 22 degrees. Then the sine angle of reflection that we have here, it is 15. So when I do the computation here, sine 22, I'm going to get 0.3746. Then when it comes to sine 15, I'm going to get 0.2588. Okay, so 8 Then when I divide, I'm going to get 1.5. So usually as for the refractive index, it doesn't have the units because it is a ratio. So in an exam, they can also ask you, why does the refractive index doesn't have the units? So you can say because it is a ratio. So as for B, it is saying, state the value of the angle A shown in figure 4.1. So if this angle here, it is 22, then we can say this one is going to be the normal ray. So the normal ray and the surface of the grass block, they are going to make a 90 degrees. So the O angle here is going to be what? 90 degrees. Now from this 90 degrees, we are just removing this angle here, which is angle 22 degrees. So we can say 90 degrees minus 22 degrees. Then the answer is going to be 68 degrees. So this one is our answer. Then as for C, it is saying, light travels at different speeds in different materials. State the speed of light in a vacuum. So in the vacuum, this vacuum here means what? Air. So the speed of light in the air or in the vacuum, it is 3.0 multiplied by 10 to the power 8 meters per second. So this one is the answer. Now let's just try to see the last question, which is coming from the activity, and it is saying, the nucleus of uranium-238 is represented in nuclide notation as uranium-238 having the symbol of U and the proton number of 92. Question A, Roman number 1, it is saying, state the meaning of the nucleon number of a nuclide. So this term here, which is the nucleon number, we can say the other name is going to be the mass number. Now to bring you back, in grade 10, we can say the mass number is equal to the proton number plus the neutron number. So for you to have the mass number, you need to add the proton number plus the neutron number. So to define the nucleon number here, or the mass number, we are going to say the nucleon number is the total number of all the protons and all the neutrons in an atom. So we can say the total number of all the protons and neutrons in an atom. That one is the answer. Then as for Roman numeral number 2, it is saying, state the value of the nucleon number of uranium-238 having the symbol of U and the proton number of 92. So the nucleon number is just the mass number. So the mass number of this uranium is just going to be what? 238. That's the mass number. Let's see the next one. So the next one is saying, a nucleus of uranium-238 decays by emitting an alpha particle. It becomes a nucleus of thorium having the symbol of capital letter T and small letter h. So when an element is undergoing alpha decay, what usually happens is like this. Now mind you, when you talk of alpha particle, these alpha particles, we can say these are just particles that has the nature to that of what? Helium. So if uranium-238, you can say 238, when this one here undergoes the alpha decay, thorium is going to be produced, which is having capital letter T and small letter h, plus the nature to that of what? Helium. Because as for alpha particles, they have the nature to that of what? Helium. And helium, it has the mass number of 4 and the proton number of 2. So in writing the decaying equation, at the end you can say plus energy. Now according to this equation that we have here, when an element is undergoing the alpha decay, a daughter nuclide is going to be formed. Now that daughter nuclide which is going to be formed, what is going to happen is that the mass number of the parent nuclide is going to be reduced by what? By 4. So in short here, I'm just saying this mass number is going to be reduced by what? By 4. This 4 is coming from the mass number of this helium. So we can say the mass number of thorium now is just going to be what? When we say 238 minus 4, we are going to get 234. Then when it comes to the proton number or the electron number, always when an element is undergoing alpha decay, the proton number is going to be reduced by 2. So in this case here we can say 92 minus 2. Then the answer here is just going to be what? It is just going to be 90. So these are the values for the mass number and the proton number that we have now for the thorium. So let's see now the first question, which is Roman number 1. It is saying, state question 1, the nuclear number of an alpha particle. So the nuclear number of an alpha particle here, an alpha particle, it has the nuclear number of what? Of 4. So here we can say we have what? 4. Then as for 2, it is saying the proton number of an alpha particle. So an alpha particle here, it has the proton number of what? Of 2. So we can say here we have 2. Then as for Roman number 2, it is saying, in nuclide notation, the thorium nucleus formed is written as, we have X, which is the mass number, Y, which is the proton number, having the chemical symbol of capital letter T and small letter H. Then the question is saying, state the values of number 1, X, which is the mass number of thorium. So in this case here, as you can see here, what is the mass number of thorium? So the mass number of thorium here, it is just what? 234. Then when it comes to Y, which is the proton number, so what is the proton number of thorium that we have here? It's just 90. So we can say 90. Then as for C, Roman number 1, it is saying, how many electrons are to be found in a neutral atom of uranium-238? So as you can see here, the proton number is equal to the electron number. So the answer here is just going to be what? 92. Then the last one, which is Roman number 2. Where in the atom are these electrons to be found? So these electrons are to be found in shells or orbitals. So we can say in orbitals, or we can say the shells. So that was the last one. If you are new to this channel, subscribe for more videos like this. Thanks for watching.